Hello. This is questions about magnetic fields interacting too. I believe I understand why now that the magnetic fields want to separate. And I did this with the help of magnetic viewing film. Anyways, I'll show you the ferrocell view of one magnet. As soon as it turns on, there we go. Okay, so as with one magnet, you get that expansive field, how the field fills up the entire around the magnet. It's not compressed anywhere. And when you do two magnets, which I'll just turn this one into 2, you get the fields being pushed out to the sides. That's because there is a dielectric plane, or what they call a block wall, probably named after somebody, I'm not sure. But anyways, down the center of the two magnets, and the fields which want to expand like a single magnet can't. So they push against that wall and force the field out to the side. And that's why you get a quadrupole effect with two magnets on the side. It's steaming up. So anyways, with the magnetic field viewing film, this is how I saw it, because putting the magnets on the end, you get, I hope you can see that. Maybe I'll take that away. It's hard for me to tell in the camera whether you can see that or not. Right there. Let me bring the camera down. I'm trying to avoid reflections. I got it in the plastic bag still. If I take it out, it's very reflective material. So you can see down the center between the two magnets, there's a line. So that's another dielectric plane. See, if I turn the magnet over on its side, then you get that 4 field effect. And that's 2 dielectric planes. That's the one going this way and the one going this way. It seems that a dielectric plane always divides a north and a south, or a north and a south, whatever it happens to be. So because these magnets are north-south, north-south, then there has to be a dielectric plane going down this way as well. And there is, because when you bring it over, you can see it. Right here, hopefully you can see that, or right there, is the one that goes across the magnets of the north-south. So when you put that in the ferrocell, and the one thing about a ferrocell is you can't really see the dielectric planes like you can with the field viewing film. Now I know why these fields push out, because there's a dielectric plane here. And when you put the magnet like this, it acts like it's 4 magnets on end, because, well, it's because there's a dielectric plane going this way and a dielectric plane going this way. And that is why the fields separate and go out towards the corners here and go out against the edges here. It's because there's a plane that way, and there's a plane this way and that way. Underneath the magnetic field viewing film, I'm going to show that. I'm going to take it out of the stupid bag and see if we can do this maybe with a closer view. Okay, I have it on the cardboard. It's very reflective. That's sort of a problem. So if I could put it on top of the field, let me bring the camera down so we can get a better look at that. Okay, so there we go. That's sitting on top. So you can see that there's two dielectric planes. Right? One going through the magnet this way and one going through beside them or in between the two magnets that way. If I hold it under, let's put it under. Now you can see it clearly that there's dielectric planes, and now I can move it. Now let's hope we can get a visual here that's not too much reflection. I can go along. Oh geez, this just isn't working, is it? Anyways, I think you get the idea. And that's why the fields are separating, because they can't go through the dielectric plane, but they want to expand anyways. So they expand and push away. Okay, anyways, so that's that. I hope that explains it, and I hope that's correct. Anyways, I'll upload this and talk to you later.